All, good evening. This is Linux session. So let's start. So, okay, for everyone who have already enrolled. So yesterday we have completed the system and service management. So we have looked at a lot in that module. So today we are going to start the disk management. Okay, so I'm going to share my screen now. Okay, I hope you can see my screen. All right. So in this disk management, let's have a look at first what are we going to learn. So the agenda goes something like this. So we will be learning what a partition is in the first place and what is its significance, and uh, and also there are different commands for listing partitions, like fdisk command and then parted command. There are others as well, and then we will be looking at formatting a partition with with file system, how to mount a partition, how to create them first. And then we will also be looking at the differences between fdisk and also the parted command. And also we will be looking at loop devices, okay, logical volume manager. And in that we will be looking at volume group, logical volumes, and how to extend them, and also file system checks and disk cloning. And of course, analyzing disk usage, we have a few commands. And finally, lsof command, and then we will be looking at how to enable or disable swap memory. So, in a nutshell, this is all we are going to cover in this module, disk management. Okay, so let's get started now. Okay, everyone, I request to please keep on mute. Let's get started. So, yes, disk management in Linux it definitely plays a very crucial role, because it's like a fundamental aspect for everyone, including system administrators or DevOps professionals, or basically everyone who's working on Linux-based environments. It's really crucial to understand this. And let's first talk about what a partition is. So partition is nothing but it's a logical division. Okay, a logical division of a physical storage device such as your hard drive or any SSD. So this allows for creation of separate areas, and it also allows to modify that size. Okay, so now let's talk about its significance. Partitioning is really important? Why can we not directly operate on the entire disk? Why should we really partition a disk? File system organization. So yes, partitioning really helps in organizing the file system because we can divide the device into different sections. And also, of course, data isolation. If you, for example, if you want to have a separate partition for operating system files, and then you want to have a separate partition for system backups, or again like that, you can isolate data into different partitions. And multi-boot configurations is also possible. You can have different OS, okay, different operating systems, bootable files installed in different partitions. That is also totally possible with this. And resize and managing storage. Okay, resizing and managing storage. So yes, we can also resize partitions to accommodate changing needs, correct? And then data recovery is also possible because if system fails, or in the event of any data corruption or something happens, then in that case, if you have a separate partition for backup, then it really helps in data recovery, and thereby it also helps you in uh, you know uh, adhering to this security and stability. So now listing partitions, we have different commands for listing partitions. So fdisk parted, and also lsblk, and also df. So now let's have a look at them. So I have my VM already up. So fdisk -L is to list all the devices, all the disks. So I'll just increase the font size. All right, so you can see a few devices over here. So okay, so you can see here /dev/sdc/sda, correct? And in that again SDA we have two partitions, SDA1 and also SDA2. And SDA1 contains bootable files, and that is why it is star here mentioned. And similarly, we have another disk that is SDB. Okay, and here dev mapper CentOS root, these are logical volumes. Okay, these are managed by logical volumes. So while we discuss logical volumes, we will talk more about that. But as of now, CentOS is actually the volume group, and root is the logical volume that is created out of CentOS. Okay, and then we have another logical volume, dev mapper CentOS, and this is for swap. Okay, so basically fdisk is one among all the commands to list partitions actually. So if you want to understand more about what is listed over here, this is the total size of this partition, 21.5 gigs, and this is in terms of bytes, and this is these many sectors. So sector is actually, it consists of 512 bytes. One sector is equal to 512 bytes, and if you multiply this with this, you will get these many bytes. And sector is nothing but the smallest, okay, unit of storage for IO operations. Okay, and logical sector size and physical sector size both are 512 bytes only. Okay, so here IO size, minimum IO size and also the optimal IO size is 512 bytes, which means that for a single operation, 512 bytes block is going to be uh, performed, whether it is read or write. So more or less similar information is given down for every device. Here you can see disk label type, and this is DOS. We have different types of disk labels actually, or you can say partition table types. So one among them is DOS. DOS is nothing but a disk operating system. Okay, we will look at that also. There are different types of partition tables. And then disk identifier. This is a unique identifier, okay, for this particular disk. So that is more or less everything about fdisk command. And then we have also looked at parted. So I've given parted -L. So it gave again a list of different partitions. And it gave again almost the same information, sector size, disk, and also the disk flags. And if you see here, it says error, dev SDB unrecognized disk label, because this device is, there is no partition table created for this device. So that is why it says partition table unknown. So Linux device mapper for logical volumes. So pretty much same. Okay, next LSBLK. LSBLK means list block devices. It gives you also the same information. It lists all the block devices that are there, SDA, SDB, SDC, SR0. You can see something like this. Okay, and here it gives the data or the output in a tree format, right? So there is some major numbers and minor numbers also for these specific devices to identify these devices. We'll look more of that in a while. And here RM means whether it is removable or not. So if you see 0, they are not removable, and if you see 1, that is removable. And this is the total size of that disk. And RO indicates whether that device is a read only or not. Okay, all are 0, which means they are not read only, they're both read and write. And type disk. Okay, you can see this SDA is of type disk, and this one CentOS root, the CentOS root is of LVM, correct? CentOS swap is also of LVM, and this is also a different disk, because SDA1 and SDA2, these are two different partitions, so that is why the type is mentioned part. And then to the extreme right, we can see the mount point. Okay, at what directory this device is mounted, so that we can access those files. So SDA1 is what contains all the bootable files, and that is mounted at slash boot and slash. So what do you mean by slash? This is the entire file system, correct? So that is okay. It is mounted at slash, and also swap. So these are currently not mounted, so that is why it's not showing anything. And similarly, if you give df-h, this shows you file system at file system level. This gives you the output for device based, and this is for file system based. And the total size of that device, how much is used, how much is available, use percentage, and mounted on which mount point. Okay, so these are all about different commands to list all the block devices. And now let's continue. Okay, so using the fdisk command. Okay, so before we start this actually, okay, so before getting into this, let's talk about block devices. Okay, let's first understand from the block devices, and then we will get back here. So if you might know, there are different types of block devices, we all know, right? uh, and that totally depends on the interface, like SATA or USB disk, or you know, SCSI disk, correct? And again, we have different kernel modules also, and they are used to access the physical device or to interact with the block devices. So we can give mod. ls mod command, it lists you all the kernel modules, and it also lists all the device drivers as well, right? Device driver is just one type of the kernel module. And here we are particularly interested in sd underscore mod. Okay, sd underscore mod is, okay, this is the kernel module, or this is the device driver that interacts with SCSI devices. Okay, if you want to see more information about that, we can give mod info sd underscore mod. So you can see a brief description about it. SCSI disk driver. Okay, all the SCSI disks, okay, they will be managed by this driver, SSD underscore mod. But having said that, how do we really differentiate between this, like which device is managed by which driver? So as of now, there is no differentiation. All the devices, all the block devices, whether it's SCSI or USB or SATA, everything as of now is managed by SD underscore mod only. Okay, this one only. So here, this is also important. Alias. So you can see alias, block, major. So there are different numbers over here. So these are nothing but the major numbers. Major number is nothing but a unique number that is used to identify a device driver. And in this case, SD underscore mod, we have these different major numbers, but we mostly see 8. If you give ls block command, observe here, ls block command I just gave. So major number is 8 for SDA, correct? And also for SDB, it's 8. And also similarly for SDC, also it's 8. But for logical volumes, it's different, 253. Okay, that is that. So that is a testimony to the fact that all the block devices are managed by SD underscore mod device driver. I hope it makes sense, because the major number is what it determines. Okay, because kernel should know which device driver is it should use to interact with this block device. So by giving this major number 8, it identifies that SD underscore mod is the kernel module that is used for interacting with these block devices. And similarly, for LVM, the device driver is again different. So that is why you can see the major number is different, 253. Okay, so there are different device drivers. Kernel maintainers are, those those are the ones who assign these major numbers for device drivers. Okay. So for SD underscore mod, you can remember this number. It's 8, and for logical volumes, it's 253. So we were talking about LS block. So if you want to specifically list information about any particular block device, for example, /dev/SDA, it gives only about SDA. Okay. So we have talked about major number, but what about this minor number? So minor number, it's nothing but it indicates the partition number. That's it. SDA1, it will be 1. Okay, for SDA2, it will be 2, and for SDA3, it will be 3, and so on and so forth. So minimum minor number is, it indicates the partition number. That's it. But major number specifies the device driver. And if you want to look, so this is a downwards tree, but if you want to look back up the tree, you can give -s/dev/SDA. Okay, so now let's talk about, let's continue Fdisk. So using Fdisk command. So the purpose is partition creation, partition modification, and of course partition deletion. Okay, you can also use parted command. Okay, so let's talk about this Fdisk. So to launch Fdisk for a specific disk, so you can give Fdisk and then whatever the disk that you would want to manage. So Fdisk usually provides an interactive interface. Okay, so where you can enter commands and follow prompts to perform partition management operations. So it gives you an interactive interface in like, which is different from what we normally give commands from the CLI. So these are the options that you encounter to, okay, to manage this disk: M, N, D, P, and W. Okay, so let's go ahead and create a partition with Fdisk. So I've just given ls block command. So now let's use SDB. So this is of the total size of 20 gigs. Okay, Fdisk. And now since we are talking specifically about SDB, we need to give SDB/dev/. Okay, so now if you observe, device doesn't contain a recognized partition table, building a new DOS disk label. So if you might remember, previously when we gave the fdisk command, it has thrown an error. It said partition table unknown. But when you give fdisk command, it has created a partition table for it. So now it entered into an interactive mode. So if you press M, it gives you a list, okay, a menu of what you can do with this. So since we are talking about creating a partition, so we need to give N, and this adds a new partition. So let's give N. Okay, so here it's asking to select the partition type, whether it is primary partition or extended partition. So there is a difference between primary and extended. Okay, extended partition, you can use this for creating logical partitions out of that. But primary, it's creating partition out of the underlying physical storage. But as of now, let's use the default one, that is primary P. Okay, next it asks the partition number 1 to 4. You see, it has restricted us to 1 to 4 only. We can create at max only 4 partitions. And out of that 4, 3 are primary and 1 is extended. So that is a limitation for us. Okay. And let's choose the default one, because since we are creating the partition for the first time, obviously this is going to be the partition 1. So now it asks us to select the first sector. You remember what a sector is? So the default value is 2048. Now it asks for the last sector. If you press enter, if you choose the default one, it's going to consume the entire space. So let's just use 250 megabytes. So anyway, this is of total 20 gigs, I guess. So let's just create a partition of 250 megabytes. Okay, so partition 1 of type Linux and of size 250 megabytes is set. It says over here. So if you want to print this table, okay, you can give P. Okay, so we have not created a partition just yet because we need to save these changes. So W is what we give to write table to disk and also exit. So let's give W and press enter. So that's it. If you give lsblk again, so SDB1 is created now, and this is of type partition, and this is of size 250 megabytes. Okay, and minor number is 17. Okay, so let's talk about these minor numbers in a while. Okay, but as of now, SDB1 is created, right? We have successfully created a partition. Okay, that too using Fdisk command. So now that we have created a partition, we also need to add a file system to it. Okay, or let's say we can also say like formatting a partition with a file system. Okay, so this is what we have just done exactly, creating a partition with Fdisk. So we just identified the disk which we want to create a partition from. So we chose dev.sdb, and then we have launched Fdisk by giving Fdisk dev.sdb, and we have created a new partition. So inside that interactive interface, we gave n, and then we have selected the partition type. Okay, and then we have also specified the starting and the ending sectors, and then finally we have set the type. So and then we have saved the changes and exited out. Okay, but we have not formatted the partition, and we have also not mounted it. Okay, we will do that. So what do you mean by formatting a partition with MKFS? So formatting is nothing but it's just preparing a partition to store files and directories by creating the structure, the file system structure and metadata. So for creating this, so for formatting it with a file system, we use MKFS. MKFS means make file system. So this is what we use for adding a file system. Okay, and we can use different file system types, ext4 or xfs, pt, rfs, anything. So this is the command to format a partition with a specific file system. So it has to be mkfs dot and any file system, whether you want to you can use anything, ext4 or xfs or anything, and then the partition name of the partition. And also remember, if you are going to format a partition with a file system, then it erases all of your existing data. Okay, so and after that is done, of course we will be accessing that data. So to do that, we need to definitely mount that partition at a mount point. So this is used to attach file systems and partitions to specific directories, and this mount point has to be existing before, okay, before we give the mount command. All right, so okay, so this is for integration into file system hierarchy, and this is the basic syntax: mount, and then the partition name, and then the mount command. We can also verify that using df or the mount command. Let's do it. So here we are, SDB1. So this is what we have created a partition, SDB1. So now let's just go ahead and format this with a file system, mkfs dot Let's use XFS and then /dev/sdb1. So it's done. So once you format a partition with a file system, you can check that also by using this blk id block id /dev/sdb1. So when you get this id uuid, which means this confirms that this partition is now formatted with a file system. We have successfully added a file system. If you do not get any output of this command block id, that means it's not done. And this is also showing of the type is equal to XFS. So yes, formatting is done, added a file system successfully. Now the next step would be to mount this partition. So for that, mount /dev/sdb1, and then let's use the mnt. All right, so this is done. So you can check in two ways. You can give df-h. So file system dev sdb1. Okay, this is approximately of size 247 megabytes, and this is mounted at /mnt. You can also use the mount command to check that the last line, because that is what we have just recently added. So /dev/sdb1 is mounted on /mnt, and this is of type XFS. But if you observe the mount command output, it gave you almost every information regarding the mounts. But if you want to specifically narrow down this output to only XFS file systems, you can give -t. So it shows only the file systems of type XFS, SDB1, okay, of type XFS. So, so that's it. We have successfully used fdisk command. Okay, so now let's continue. And for unmounting partitions, you can simply use umount. Okay, so umount and then the mount point. You can again check it using the df command or the mount command. It's not unmount, it's umount /mnt. And if you give the same command again to check it, so now it's gone. Okay, so that's it. Okay, so now let's understand the comparison between fdisk and parted command. So we will see parted command more while we discuss the loop devices. But the only difference here is, okay, the partition table format. In terms of the partition table format, the difference is fdisk primarily supports master boot record. Okay, and parted supports both mbr and also GPT. So I was talking about the partition table types, correct? So these are the two types, MBR, the first one, and then the second one is GUID partition table or GPT. Okay. So the difference here is with MS-DOS table, or MS-DOS is also called as MBR. So we gave fdisk command and it shows us disk label type DOS. So this device SDA is /dev/SDA is currently using the partition table MS-DOS or MS-DOS, or you can say MBR, both are same. Or master boot record MBR is, okay. So the difference here is, so with MBR, you can have a partition size of maximum 2 terabytes only. Okay, and this supports up to only 4 primary partitions. Okay, if you might remember, while we created a partition, it okay, it shows us some limitation. You can only create 4 partitions, and out of that 4, 3 can be primary and 1 can be extended. So again, this is a limitation over here. The maximum size can be 2 terabytes, and the total number of primary partitions can be 4 only. But if we talk about this, okay, GPT, This supports up to 128 primary partitions. And also, this is not mentioned over here. The maximum size is it supports is 8 zettabyte. Okay. And in terms of interactive versus scriptable, Fdisk it operates in an interactive mode. So we have just done that. Okay, we have entered into an interactive interface and we gave different options. But parted, it can be used in both interactive and also in scriptable mode, which means we can give commands directly with parted. It is okay possible with parted both interactive and also the scriptable mode. So those are basically the differences. Okay. So now let's talk about the loop devices. So any questions so far?
No, we are good.
All right. So now let's talk about loop devices. So loop device it's a virtual block device. Okay, so you can use a loop device to mount a file as if it is a physical device. Okay, for example, you if you run Linux in your machine, definitely you will have bootable files in your physical hard drive, correct? So instead of having a physical hard drive, you can use a loop device. Okay, you can use an ISO file, and that exactly represents the physical hard drive. So this is mostly useful when you really want to cut down the cost or when you don't want to buy another hard drive or something, then you can use these loop devices. The loop devices, they work exactly the same way as any other block devices. They're exactly the same. But the only difference here is a file represents a block device. Okay. And that file is normally a disk image file. So So I hope it is clear. So loop devices, in a nutshell, they are used to mount disk image files. So there is a backend file that is linked to a loop device. Okay, and that backend file represents the device, represents the physical storage device. So I have here ISO file. So I'm going to use this ISO file. Okay, let's just download this. You can use anything. This is of size 36 megabytes. Okay, wget is not installed. Let's install it. Okay, so I have just downloaded this ISO file. You can use anything. It doesn't matter what is there inside it. Okay, so just to understand this, so this is my disk image file. So this disk image file is going to represent a physical block device for me now. Okay, so now we are going to create a loop device and we map that loop device with this file, ISO file, so that the only point here is you don't really need to have another physical hard drive. You can just have an disk image file and you can map that disk image file to a loop device and you can use that loop device. Okay, like any other block device. Okay, so now we have just downloaded this ISO file. So we can give LO setup command to check all the existing loop devices. So I've just given LO setup command. It gave me nothing. So currently no loop devices are created or existing. Okay, so now let's create one. So to create a loop device, we give hello setup. So loop devices are of the order, okay, they are of again different series. Like we have for SDA, SDB, loop devices are of different series. They are usually starting from dev loop 0, dev loop 1, and so on. So I'm just using the dev loop 0 as the name of the loop device. So obviously we need to map this loop device with this ISO file. Okay, so we have just created a loop device. Let's check LO setup. Right. So now you can see the name of the loop device, dev loop 0. Okay, and you can see here this is backend file. This loop device is mapped to this ISO file. Okay, and this represents, okay, this device. The Okay, I hope it makes sense. So now we have successfully created a loop device. You can use ls block command also to check it. So loop 0 is what it is created. And now you observe the major number. This is 7 now. Okay, and so we can now conclude a fact that loop devices are again managed or interacted with a different device driver, which is different from sd underscore mod, and that is loop, mod info loop. So loop is the kernel module, okay, that is used to interact with loop devices. Okay, so that is why this major number is different. So like any other block device, you can also create a partition out of it. You can add a file system, mount it at a mount point like any other block device. Okay, so let's mount it. No, okay, so here not required to really add a file system because ISO file itself represents uh, a storage device, correct? It will already have data inside it, file system structure inside it, so we don't really need to add a file system to it. So now let's mount it. Slash dev slash loop 0. Okay, so it says dev loop 0 is write protected, mounting read only. Yes, of course, it's an ISO file. It's okay if it is write protected. So now let's check mount. So dev loop 0 is mounted on slash mnt. So now I have just listed the files at slash mnt. So you see these are the different files that we can access, okay, that are a part of that ISO file. So let's unmount it. So I've just unmounted it. So when you unmount it, the loop device will not be gone, it will still be there. Okay. But if you want to delete this loop device, or deleting a loop device means detaching a loop device with this file. So for that, you can give hello setup -d for detaching dev loop 0. So now let's check. So it's gone. The loop device that we have just created is gone. All right. Okay. So that is a very basic understanding of loop devices. All right. So now let's understand this major number is what we have seen already. So what is all about this minor number? So if you see it's 0, 1, 2, but if you see here it's 16, 17, and if you see here it's 32. So what is this all about? So basically, like I told, sd underscore mod, this is the kernel module for all the SC, SI, and also USB or SATA or any kind of disk devices. This is the kernel module, okay, that interacts with these devices. So that is what I told. Major number represents a unique, it's a unique number that represents a device driver, correct? But again, there is a limitation for using these drivers sd underscore mod. If using this sd underscore mod, there is a limitation. Like for example, if we talk about sda, of course the major number is 8 only, okay, because sd underscore mod is the kernel module, and the minor number can range anywhere between 0 to 15. So it can have a total of 16 partitions. So likewise sdb is equal to major number will never change, okay, because sd underscore mod is like all season kernel module. It never changes for block devices only. So for SDB again, it continues now. It's 16 to 32. So like so on, we will have until SDO. So here the major number will still be same. I think it starts from 240, 240 to 255. So when you create a partition out of SDA, the first partition will be having minor number 1. The second partition will be having minor number 2. So likewise, if you are creating partition out of SDB, the first partition will have minor number 16 and the next 17, 18 and so on. So that is what we see over here. For SDB, it starts from 16 and for SDB1, it's 17. Okay, for SDC, it starts from 32. I hope it is clear. So like that. So that is all about minor numbers. Minor numbers represent partitions while major numbers represent device drivers. All right. Okay. Okay. So next we have. All right. So next it's raw disk files. So now that you have seen that we have downloaded an ISO file and then we have linked that with the loop device and we have did that all. But you can also do the same along with raw disk files. Okay. So actually, mounting a disk image file is just one use case of loop device. There are many other use cases of loop devices, but as a part of disk management, we have looked at only this. Okay, mounting disk image file. And now let's talk about this raw disk file. So like an ISO file, you can also use this raw disk file. Okay, and then you can create a loop device and then map that loop device with the raw disk file. Okay, and then you can add a file system and then you can do normally. So what a raw disk file is, what is it first? So raw disk file is nothing but it's a binary representation of a physical storage device. Okay, it's like a copy. Okay, it's like a copy of a physical storage device. You can think of it that way. And this copy includes everything, including data, file system, or even empty space also. So that is what a raw disk file is. So you can also create a raw disk file. We have different commands for it, like dd, okay, disk duplication, and then we have fallocate command. So by using these two commands, we can create raw disk files. Okay, let's do it. Okay, so you can observe a difference here. So there is a difference actually between using dd and fallocate command. Okay, fallocate command is much faster when compared with dd command. Okay, so how do we really understand whether this is faster or not? We can use time command. You can use time command before any command to check how much time it took to run that. For example, if I say time sleep 5, you can append this time before any command. So it just gives you at the end of that output how much time it took. So it's you see 5.011 seconds. So just to understand which one is faster, we are appending time command before these two. dd. So here we have the basic syntax. Okay, if represents the input file because we are creating a raw disk file which is a binary copy. So of course we need to have a input file. So here I'm using /dev/0. Okay, dev0 is nothing but it's a special device that generates null bytes. So I'm going to use that. So now we have to also specify the output file. Let's say dd.disk, because we are doing this with dd. Let's say dd.disk. Okay, and then we also need to mention bs. Okay, so bs is nothing but the block size. Okay, so bs is equal to, you can say, 1 megabytes, and then finally count is equal to let's say 500. So what does this mean here, bs and count? So bs determines the amount of data that dd should read from input file to output file in a single operation. In a single operation, 1 megabyte data will be transferred. And how many such operations should be performed? 500. That is the count. So the output file dd.disk is going to be of 500 megabytes size, because 1 multiplied by 500 here. Okay. So how much time it took? 1.595 seconds. And now let's use fallocate. Fallocate, fallocate, and then we can give -l just to specify the size. Let's mention the same size because we are understanding the difference here. So this time let's give the name as fa.disk. So now you observe it's 0.0. This is phenomenally quicker than this. It's 1.59 and it's 0.1 seconds. Okay, so these two are the ones that I have just created, raw disk files, td.disk and fa.disk. So now that we have these two raw disk files, what we'll do, we will just go ahead and create a loop device, and then we'll map this with the loop device. Let's first check if we have any. All right, hello setup. So hello setup. This time I'm giving -f. Okay, -f is to mention that hello setup should take the available loop device as a name of the loop device. Instead of mentioning the name of the loop device, you can give -f. Okay, so let's use dd.disk. So by default, the first available loop device is dev loop 0. Now I'm giving -f fa.disk. If you check back, second time it created loop 1. That is what -f means. It should find the next available loop device and it should create a loop device by that name. Okay, so let's detach this. So we have as of now only one loop device. Okay, so yeah, we have created a loop device, and that is dev loop 1. So you can use these for creating these disks, raw disk files, or you can use any other disk files also that you have. So now let's create another one, fallocate, and let's say it's of size 1 GB this time. Okay, so let's also specify the location. Let's say var let's say disks, and let's disk 1. Okay, so we just need to first create that. All right, so this has created a raw disk file in this particular location, var disks and disk 1. So let's just remove all the devices. If you mention -d, uppercase D, it detaches every loop device that is available. Okay, everything will be gone. Okay, so now let's do it. Let's attach it. Hello setup. So let's specify this time loop 1. Okay, instead of saying -f, we want to specifically give it a name, that is dev loop 1, and the location of the disk file, disks, and then disk 1. Okay, all right. So we have just created this. So let's now create a partition out of it. So like we did with fdisk, same here also. Fdisk dev loop 1. So it also says there is no partition table recognized. So if you print M, it gives you the menu. And now let's say N. Okay, so let's select the primary P, partition number 1, first sector default, last sector, let's give 500. So now let's save and exit. Okay, it says rereading the partition table. Okay, now let's give part probe just to make the kernel read the changes. Okay, all right. So you can, you can give ls block command also to check. So you see loop 1 partition 1 is created and that is of size 500 and the loop type. Correct. Now if you observe the major number is again different. Now it's 259. Okay. So we have just used fdisk command to create partition. You can also use parted command. So let's detach everything. Okay. So now let's use parted command. Okay. Okay, let's use dev loop 0 this time. Okay, let's create again. Okay, yeah, we need to also mention the -l. Okay, so lsblk we have here loop 0. So now let's go ahead and use parted command, okay, to create a partition. So the difference between parted and fdisk, you can use directly commands to create partition using parted command. Okay. Okay, so now let's say parted /dev /loop 0, and we can say print. Okay, to print the partition table. So it says partition table unknown. No partition table is created yet. So for creating it, we can give parted and then the partition name. Okay, mk label. Mk label is what we give for creating a new partition table on this particular partition, and we use ms-dos. Okay, so now this is done, and now let's create a partition. If you observe, we are directly giving commands to create partition instead of performing through interactive mode. So parted the partition of the, okay, dev loop 0, and mk part is what is Okay, this is what is used for creating partition. And we also need to mention the type of the partition, primary, and then the first and end sector. So I'm going to use the from the beginning and till 25%, which means it's going to use the 1/4 of, okay, this loop device. So now it has created the partition. If you want to check lsplk, so now that we have a partition loop 0 partition 1. Okay, so after this is done, we also need to format this mkfs.xfs. Correct, you can format a file system with any label being attached, or you can not give label. It's okay, it's totally optional. And this label is not any specific to any file system. Okay, let's say data. So hyphen L is to specify the label, and of course the partition loop 0 partition 1, because this is what we are going to add a file system to. All right, so now let's go ahead and mount it. So for mounting, you have directly used the loop device like mount dev loop 0 p1 and also the mount point. But instead of that, we can use the label to mount. Okay, you can give mount and then label. Label is equal to the label that we have just given. So you can use this also for mounting. Okay, slash mnt. So if you want to check, so I'm specifically narrowing this output down to XFS only. So loop 0 partition 1 is mounted on mnt. Okay, and there is another way also. Let's unmount it for a while, slash mnt. Okay, so blk id is what we use to get the file system id, loop 0 partition 1. So this is the uuid. Okay, so let's just copy it. We can use this also for mounting. Okay, mount, and you can specifically specify that uuid over here, and then give a space and then say mount at the mount point. So that's it. So that's it, team. We have done everything. Okay, so we have tried fdisk and also parted, and also uh, we have looked at the raw disk file, how to create them, what are the different commands that are available for it, right? So that's it for today's session. So, and yeah, we were using the loop devices actually. So if you try and reboot the system now, all the loop devices that we have created, they will be gone. Okay, so then what is the use? Okay, so we can also purchase loop devices across reboots. Okay, how we can